Ever wondered why an apple falls straight down from a tree and not upwards or sideways? Well, that's gravity at work for you. But what exactly is gravity? How did we come to understand this mysterious force that seems to govern the very cosmos itself? Our journey begins in the 17th century with the great Sir Isaac Newton. One day in 1687, he famously observed an apple falling from a tree. Instead of simply enjoying a delicious snack, Newton asked why. Why does the apple fall straight down? This simple question led him to formulate the law of universal gravitation, a cornerstone of classical physics. Newton's law states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This is a fancy way of saying that the bigger and closer objects are, the stronger the gravitational pull between them. But gravity isn't just a force that pulls apples to the ground, it's a fundamental force that shapes the universe. It's why planets form spheres, why they orbit the sun, and why our Milky Way galaxy spins in a beautiful spiral. However, not all planets experience gravity in the same way. The force of gravity on a planet depends on its mass and size. That's why you'd weigh less on the moon than on Earth. Its gravity is only 1/6 as strong. Now, you may have heard of magnetic fields and wondered how they relate to gravity. While both are fundamental forces, they're not the same. Magnetic forces are caused by the motion of electric charges, while gravity is caused by mass. One is a push-pull force that can attract or repel, and the other is an always attractive force. But wait, isn't there something called acceleration due to gravity? Yes, there is. But it's not the same as gravitational force. The acceleration due to gravity is the acceleration of an object caused by the force of gravity. On Earth, this value is approximately 9.8 meters per second squared. So, where does this leave us? Gravity, first understood by Newton in the 17th century, is a key force that shapes our universe. It varies depending on the mass and size of a planet, and while it's related to other fundamental forces like magnetism, it's not the same. And while gravity is a force, the acceleration due to gravity is a result of that force at work. In essence, gravity is a beautifully complex force that holds the universe together. From apples falling from trees to the motion of galaxies, it's a fundamental part of our cosmos. And even now, centuries after Newton, we're still unraveling its mysteries.